Welcome back everybody. In this video tutorial I'm going to talk about slant asymptotes, or what they're also commonly referred to as oblique asymptotes. Recall in the horizontal asymptotes video, if the degree of the numerator is higher than the degree of the denominator, we said that there is no horizontal asymptote, which is true. However, there's a special kind of asymptote also called the slant or oblique asymptote. In order to find the slant asymptote, we must divide the numerator by the denominator using either long division or synthetic division. Now, if you're not familiar with how to do either methods, I have separate videos for each method on my channel that you can take a look at before continuing watching this video. So let's begin. Now, I'm going to use the same example I used in my previous video of horizontal asymptotes. And we had a function that looked like this. We have g of x is equal to x squared minus x over x plus 1. Now, to find the slant asymptote, like we said, we must divide the numerator by the denominator. We can use either method, either the synthetic or the long division. For this example, let's use the synthetic division. We have 1 as our leading coefficient for the term x squared. Then we have negative 1 here. So what we can do is we can go ahead and write those. We can make our table here. And then for the denominator, we have x plus 1. Remember, we have to flip the sign. So we're going to end up with x is equal to negative 1. And that's what we're dividing with. Now moving on, we're going to move 1 down here. We're going to multiply 1 times negative 1. And then we're going to end up with negative 1 here. And then we're going to add these two terms. Negative 1 plus negative 1 is going to give us negative 2. And that's our answer right here. We're going to take, since we divided by x starting with x squared, we're going to be left with x for 1. Then we have minus 2. We're just going to go ahead and write that as our constant. So basically the slant asymptotes occurs at y equals x minus 2. As you can see here, I already went ahead and graphed this function. We have g of x is equal to x squared minus x over x plus 1. We have a vertical asymptote at x equals negative 1. Then our slant asymptote occurs at y equals x minus 2. Notice how y equals x is simply the linear function that occurs here, straight through the coordinate plane. But since we move down 2 points in the coordinate system, the line stays the same, however its position is different. Let's look at another example. We have the function, we have the function g of x is equal to x squared minus 2x minus 3 over x minus 2. Now, since we used synthetic division in the previous example, I'm going to go ahead and use long division this time. And then we said we're going to divide x squared minus 2x minus 3 divided by x minus 2. We're going to go ahead and write that here. X squared minus 2x minus 3 divided by x minus 2. X squared divided by x is going to give us x, and then we're going to go ahead and write that directly above negative 2x. And then x times x is going to give us x squared. And then x times negative 2 is just going to give us negative 2x. Don't forget, we're going to subtract all these terms. X squared minus x squared is going to give us 0. Negative 2x minus 2x, which is negative 2x plus 2x, that's also going to give us 0. Then we're left with negative 3 here. Negative 3 here is going to end up being our remainder, actually. So this is going to end up as x plus negative 3 over x minus 2. Our x here is our slant asymptote. Our x here is our slant asymptote. Remember what we said before in the long division video on my channel. We said that x here, our q of x, which is our quotient, negative 3 here is our remainder, which is r of x, and then x minus 2 is d of x, which is our divisor. I also went ahead and graphed this as well. We have g of x is equal to x squared minus 2x minus 3 over x minus 2. Our slant asymptote occurs at y equals x, which is just a linear function. And we also have a vertical asymptote occurring at x equals 2, which is happening right here. Thanks for watching, everybody. Please go ahead and subscribe to my channel. Don't forget to like this video, and we'll see you next time.